Hi, good morning, evening, afternoon, middle of the night, whatever it is, everybody. Yeah, so I'm Austin, a Apache Beam committer and enthusiastic user. I guess a bit about me, I had been weirdly lurking, maybe weirdly, I guess, lurking on the Beam mailing list for a long time, paying attention. The vision of the project just seemed super cool, so I've over time, as you might have seen from Ken's talk, the journey of, pay attention, tune in, contribute. I've contributed code, and I also try to share and grow this community. I figure that's Beam is super promising, and is, after a number of years of being involved, it's really coming into fruition here as to the sort of things that you can get done. So as far as what this workshop should entail, really we're going to cover what Beam is, how to use it, using examples from Java, Python, Go. There are examples in Kotlin as well. I'm not intimately familiar with Kotlin with Beam, so I'll show you how you can use those alongside. But really a whole lot of this will either be presentation that's super generically applicable to how to write Beam, how to think about streaming pipelines, and etc. And then some hands-on exercises so that you start to feel comfortable. So without further ado, I'll start sharing what we're gonna really dig into. So outline includes an overview of Beam. We will start talking about pipeline. We will take a break for writing some exercises, otherwise known as katas here. There's small bite-sized exercises, which actually to share may seem really silly as to how small they are, but they are incredibly fundamental. And when you add component pieces together, especially, you get to deal with the full expressive power of Beam and can do some really complex and awesome things. After the first set of exercises, we will get into windowing and time. We will get into triggers and streaming and stream processing. And we will briefly talk about side inputs. Overall, these points 3, 4, and 5 really are going to be much quicker through than points 1 and 2, but they're very important for me to provide you with a holistic vision. It's, there's too many things to cover in depth in this short amount of time, but wanting to make sure you guys start getting all of the sort of fundamentals that you would. After some side inputs, we can dig into some additional katas and have some share additional opportunities around Beam. So yeah, that's what we'll cover. So as has been shared, just want to make sure you guys see this post again, beam.apache.org/blog/beam-kata/release. That has some fundamental instructions for downloading, say, PyCharm EDU, IntelliJ IDEA Community Edition, etc. Not that's required, but it'd be a shame if you have the at least ability on your work computer to download these applications to not use them to follow along. Also, in general, this is just a great learning tool that has many more exercises than we're going to be able to cover today. So hopefully you're able to get it, if not now, eventually, and work through these things, assuming you like what you're hearing and this is something that makes sense for you to keep digging into. Cool. All right, so for an introduction, what's the Beam programming model about? So the vision, as again you might have heard Ken give his take, is for Beam to be an open source, unified model for defining data processing pipelines, which allows you to write your pipeline in the language of your choice and run it with minimal effort on the execution engine of choice. So there's, a lot of kind of bolded terms there, could be a little jargony. So we're gonna go through these to make sure that people follow what we mean here, right? So first off, what do we mean by data processing pipeline? What is a pipeline, right? We take, maybe it's not these sort of, I think these are natural gas pipelines where which is not quite what we're talking about, but ultimately take some input, do some transformations, get another peak collection, do another transformation, right? Then we're grouping things into some sort of output. So yeah, this in Beam, we have our source, our P collection, do something called a P transform. P in both of these cases stands for parallel, right? So the ability to perform tasks in parallel, achieve large scale throughput, low latency. What is a pipeline? Ultimately, after writing the code, we get to pipelines being get transformed. Your code gets transformed into a DAG, directed acyclic graph of data transformations, which are applied to one or more collections of data. Say maybe these, databases. They can be bounded or unbounded. So the definition there, we mean bounded meaning batch, right? We know the start and end of the data set. Unbounded as a data stream, right? It's just coming in. We don't know if or when this might end. This is, non-trivial DAG here with multiple inputs as well as multiple outputs and various branching, I guess, strategies, right? Multiple sources and potentially multiple sinks are possible. With the pipeline as created, it gets optimized and executed as a discrete unit. So as mentioned, Beam represents data sets as P collections, and data transformations are referred to as P transforms. Pipelines can vary in shape. Branch in various ways, so you can partition things apart. Like over here, you can perform a flatten to pull things together. There's all sorts of ways to do things. All right, so what do we mean by a unified model? Let's let this. So Beam as a unified model of both, here we have batch processing and stream processing, right? Bounded and unbounded data sources with the Beam model and SDKs, which we'll dig into exactly what we mean by that, but on many runtimes, right? Flink, Spark, the direct or local runner, Google Cloud Data Flow, as well as a bunch of others. So you can write your transform and processing logic, your IOs, etc., in this Beam model, which suffices for both batch and stream processing on the runtime or execution engine of choice. Also, what do we mean by language of choice, right? The Beam model supports a bunch of different languages. Got started with Java. The Python is, and that's certainly the most well-developed. Python has come a long, long way. Go is relatively well-developed and is, imminently high quality production, but is, to hazard, it's still marked experimental, but that should change in the near future. We have Kotlin, of which there are examples that you'll be able to see as well. There is SQL dialects for Beam SQL, and Spotify has open sourced DSL on top of the Java SDK called Shio. So I'll kind of, repeat myself way too many different times just to make sure the vision and really what we're talking about with Beam comes through. Beam as a single model with multiple processing modes, batch and streaming, bounded or unbounded. It has multiple SDKs or ways of writing the code with and executing those on multiple runners. Right. So, and this just has the, I guess, kind of major runners, but really there's a ton, right, there's the direct runner. There is this Apache project Nemo, which is still an incubating Apache project. You can run things on AWS EMR or Kinesis Data Analytics, of which on Wednesday there is a workshop on specifically how to write and submit Beam jobs. I think production quality on AWS Kinesis Data Analytics, and in that ecosystem. Beam originally was the data flow model. Now it is Apache Beam open sourced, right, and is works well in Google Cloud on data flow. There's Hazelcat Jet, IBM Streams, Samza is a runner especially used within LinkedIn, and then naturally Flink and Spark are kind of more famous big data processing things. So Beam lets you, no matter where your compute resides, you can write the same Beam and submit it to any sort of these processing engines or pipeline runners. So that's, to me, that's a giant selling point as to why I would, and why I personally am a fan of Beam is I can worry about one set of essentially APIs for how I want to define my data processing pipelines, and I'm going to be able to execute it in the cloud or constrained compute environment where required. Again, here's a different way of saying the same thing. Beam as a unified model. It's portable with multiple runners and multiple languages, Java, Python, Go, Kotlin, et cetera, et cetera. I think as Ken alluded to earlier, we also now have the ability to mix and match languages in the same pipelines. It is very extensible, has a bunch of IOs from most open source, or, many of the open source data stores and streaming systems, and works in the major public clouds. Cool. So to dig in, how do we want to talk about pipelines? So pipelines describe what are we computing, where is that happening in event time, when in processing time are we calculating things, and how do refinements relate? So that means what sort of transforms are we doing, where are in event time relates to our windowing strategies. When are we materializing things? So relative to how we're calculating watermarks and triggers for emitting results, and how are we handling accumulation? I haven't updated this lately, but there is the compatibility matrix at beam.apache.org/documentation/runners/compatibility matrix, which talks about how feature complete each individual runner is. For instance, data flow relative to the expressive semantics of the Beam programming model whatsoever. So, here you can see window strategies are well implemented across runners, but there are variations between close my window. There are variations between individual runners when it comes to other aspects. Most of the basics of what you would need are well covered. Cool. I lost my other screen, but I guess that's not really the end of the world. Let's see if I can get
In the meantime, we have a couple of questions. I don't know if
awesome.
you want to address them.
This is actually a perfect time to be addressing them, no matter. So let's go for it.
Masoud Koleini asks us, why is Beam implemented in Java and not Scala to be more consistent with similar Apache projects like Spark?
So to that, I would say that would just be a preference, right? I mean, fundamentally, Spark was implemented in Scala, but I want to say Flink is Java under the hood. I mean, you can get at, I believe Kafka is primarily Scala, if I'm not mistaken, although it's been a while since I've looked into their definitive code base. I would say
it was preference for from the lead developers. And then is using runtime of choice the main motivation of using Beam over the Spark pipeline?
I think when you get into the way watermarks get handled for your streaming use cases, there is additional flexibility, at least since the last time I really dug into Spark, for like true legit record by record use cases. I haven't looked at Spark 3.0 as to whether or not that's been addressed, but certainly there was, the way you could do, individual record, and kind of handling your streaming use cases. Batch, Spark came from the batch framework and then has been slowly moving towards smaller and smaller batch processing. So, unless you need super fine grained, to me, the portability across runtimes is incredibly compelling, at least unless you're wholly, it would probably be unless you're wholly committed to a specific compute framework. But I think we see that the technology landscape continues to evolve. So I guess a question of is, are you comfortable linking your programming logic to a specific compute engine, namely, say, Spark, rather than something that, as things can potentially evolve, you could switch around. But yes, to the specific question, I would say not only the the choice of runner, but also, or choice of changing runtime, but also now the ability to mix and match languages in the same pipelines is another huge feature for Beam.
Okay. And which are use cases or scenarios where you would not use Apache Beam?
That's, I guess that's too vague of a question for me to feel comfortable asking, right? It's, and here's the reason why is, naturally it's not a solve everything problem, but there is, it's particularly well suited to big data, but fundamentally, if you understand the tools for working with massive amounts of data, it might be easier to use that same tool for small data. I'm inclined to be tooled for any scale, for instance, but I think there's, so well suited for data ETL, if you will, for batch and stream processing, although there's, we're increasing for, TFX, so a form of TensorFlow extended support, which I think there's another workshop later today. There's other things that the capabilities aren't currently extremely well developed, say around machine learning, for instance, is not incredibly Beam is not the best at that currently, but you could certainly use Beam to help feed other systems for those sorts of use cases. Just to make sure I, give some reason to,
let's do one more. Let's do one more, and then we carry on and address the rest later. But let's do one more. That's are there any differences in what can be done with Java and Python, specifically for streaming?
Yes. I mean, they are. The overall vision is that there should be no differences. As to the current state of the art, I would have to check. I think, and please don't quote me as of, today on, whatever this is,
24th.
24th of August. I believe the Python SDK currently supports both Kafka and GCP PubSub as sources and can express most of the full range of transforms, but actually with the true portability framework, which I think might be completely ready at this point. And I didn't watch the second keynote for if that included because I was preparing for this. I believe you can leverage the full Java SDK's abilities for the things that don't exist in Python. So check, as of today, if there's something specific you're looking for, and please follow up in, say, the chat room, the office hours or happy hours and whatnot for your very specific question. But in the very generic sense, no, you should be able to do any and everything in any of your languages that you want to use. Slightly open question of whether or not there's a niche use case today that might not be well served, that might be, implemented tomorrow.
Okay, let's carry on. There are some other questions, but we can address them later.
Yeah, perfect. Let me turn off this. Slack is making too many noises for me too. Cool. All right. So writing a pipeline. And yeah, that was a good spot for break. Cool. So when we're writing a pipeline, we're going to do some form of transformations. So we can do element-wise transformations, which are also considered maps in the traditional MapReduce style of, algorithm, if you will, of programming. We also do aggregation, otherwise, grouping or reducing, and we can do composite transformations using a bunch of different combinations. So to dig into the element-wise transformations, the primitive in Beam is known as a pardo or parallel do function. It performs a user-provided transformation on each element independently. So frankly, ordering is not super important in that respect, right? This will split work to any number of workers, but can be used for a lot of things. So here, for instance, is a get the key by the first letter of the word. So the example Java code is here, right? Take the input, which is defined here, which is probably a read operation, which is a pardo of a do function, where we're overriding the process element, and we are returning a key value of the first letter, which is the word at character 0, and the word. Another example, which is, simpler, not only because it's Python, the pardo to just get the first letter. So we're using the class, we're overwriting process again, but we're just returning the first character, right? So S, F, N, S, for instance. And the example of a pardo in Go, right? Same thing, here's the first letter. I didn't write up Kotlin examples, but again, you'll be able to see those if Kotlin's what you're all about in the katas when we dig into those. Okay, so element-wise transformations. Being aware that pardos do not have to be one for one, right? So they can also output, for each input element, they can output 1, they could output 0, or they could output many elements for each input element. So we did see 1 for 1 from those prior examples. In this case, you could see we could explode prefixes and say, hey, show me all of the prefixes leading up to the entire word for each input element, or filter out words that start with S in the case of here, right? So in this case, it would be, 1 or 0 output. This is, 1 to many outputs. So pardos can do quite a bit of things. Cool. So at the moment, I want to give everybody some time to ensure you are all set up and to then start working through the katas. So hopefully you have the instructions, can work through them. Would encourage just do the introduction because that's like dead simple, and you'll be able to verify that the setup itself works. And once that's good to go, do dig into the pardo kata. That again is the the massive consistently used primitive across Beam. So you'll already be, well underway once we have this pardo running. So I'm going to set a timer for probably like 10 minutes here and let you guys get set up, but certainly message as you're having setup issues or whatnot. Okay, so back. So yeah, we're walking through. Here's, pardo. Here's some Java code. We can pull up and share the slides somewhere as to how it works. Some Python code examples, some Go code examples. The fact that we can go 1, 0, or many outputs. 1 or 0 outputs, many outputs, and encouraging to start working on your katas. One thing that's caught me up many times is using PyCharm, is not actually having the Apache Beam package installed. That should prompt for it, and especially if you're trying to work with Python in IntelliJ, make sure you have the Python plugin installed, otherwise grab PyCharm video. So I'll set this here.
Justin, your slides, is it possible probably to share them anyway in the meantime if people want to go over them?
Yeah.
Share the URL.
Well, let me find. Actually, I'm going to just point people to, there hasn't been many that have changed lately, at least the core bit. Do we not have? On the Beam Summit, this is where I will put some more, but also hoping that they're up here. Awesome. So Beam, github.com, Beam Summit, and Beam Intro Las Vegas will be a, not completely, but this is about the Beam programming model and intro. So as you can imagine, the fundamentals have not changed much. So suggesting that this is a good place to grab both intro on setup as well as the slide deck that would be useful and cover all of these core concepts. See, it looks a little familiar. Let's quickly go through it. Looked like there was Python question. I'm going to work through one really quick to just show what this looks like. Pedro, is my screen showing? Just verifying?
Nope.
Okay. That's a good thing I verified then. Share screen. Here we go. All right, so I pulled up my IntelliJ. I'm going to assume everybody got connected okay. All right, so we got it. You know, here's our Beam bib, Beam dot. Welcome to Beam. Check out the overview. Write a pipeline. So we want to do something like Beam dot create. Hello Beam. So some things to. And this is just to like, okay, cool. Is everything well installed? Does it work? Cool, it was correct. Want to show a couple things about this. So core transforms, Beam dot. What are we trying to do? Hard view. What's 5 by 10 do farm, and we want to override the process method. Self yield, I think it's yield, because we're going to do one that we need both input in times 10. So I think this is going to do what we want. So what I wanted to show otherwise is, and you'll see this in the map examples, but for those of you more familiar with MapReduce, you could get the same answer by doing a beam.map with a lambda times 10, for instance, right? And just to show it doesn't always pass when I run it, this should fail because I'm doing the wrong computation. So again, you can do the hard do with a do function. You know, the nice thing with that is you can then have your classes that are do funs that perform specific bits and reuse those certainly a lot more easily than you're going to reuse lambdas in your code. But again, an example of how you can get the same output. I guess to just walk through some Java here, right? We then can do, let's see the part do. All right, so in this case, we have kind of the boilerplate code that we need. We're creating an input of these 5 elements, and we're trying to so we have an input, and we're going to apply a part do of a new do fun, which is integer and integer. And then here we go. And then we need that. We then will override a process element public void process element at element integer number. Say integer number, which is output receiver of integer out. And then we do out.output number times 10 semicolon. Let's see. What is it not like? There we go. So let's see if that works enough. Again, our input, we're calling the pardo of our do fun, where we're overriding the process element. And the job is compiling and running, and that did the trick. I'll save from getting too detailed, but I think you can see that this is with the pardo and do fun. You could also, again, do the same thing with map, the way we did it for, what's it called? Python. I'm gonna, in the interest of sharing examples, I feel like the code is well worked out. It tells you, look, and also worth, in case you wanted to cheat or you just get so frustrated, you could pick a solution and it will actually show you the answers. I guess it kind of didn't like, I got the right output, but it didn't like my formatting even. So highlighting that on, there's a ton of examples. We're going to talk through a couple others, but where you can work through a lot of the Beam semantics and on your own. So I'm going to err towards spending the next little while on sharing some more worthwhile knowledge. We will do a little bit more exercises, but yeah, I'm not going to jump into the Go or the Kotlin examples, but certainly those work just the same. So if those are your languages, you know, by all means. Cool. Am I still sharing screen, right? I think so. So let's, oh yeah, I am. Okay, so let's talk about some more element-wise transformations. We have a bunch of other element-wise transformations that are built in, right? Pardo is what we have. Really, you can create the rest of these by writing custom Pardos. Pardos can do about any sort of element-wise transformations you would need, but feel free to just use, say, filter or map elements or these sorts of things to reduce the amount of custom code that you need to write. So here's an example of filter, right? Let's just get rid of, you know, get rid of or only keep some things. Here's filter with Python. What I didn't share with Python, which I think is super cool, is using the pipe operator, you know, taking inspiration from Unix and chaining, you know, input, pipe it to this filter operation to the next thing, for instance. Here's an example of Go for things. Go is unique in that it actually needs to keep this, in this case, S, with it for, you know, the reference to the overall pipeline here. Map elements example, right? One input, one output. I mean, I guess that's not strictly true if the yeah, anyways, use map elements in those ways. Here's, create the, that's weirdly backwards. Let's create a key value pair of the word and then the first letter rather than the opposite way. Here's, we can flat map elements. We can use the keys or get the keys and the values. So yeah, a lot to do element-wise. So to now dig into the forms of aggregation that we can do. There is a bunch of possibilities, the most common and important of which would be a group by key. So take a collection of key value pairs and return a p collection of key value iterator pairs. Here's, for example, take the key value pair of the first letter and the word, group by key, and then we get key value pairs of the first letter and the iterable of the elements within. So in addition to aggregating, we can do the group by key. Here's how to do it in these fashions. How can we use group by key to get the most common value for each key though? Then one way would be to use the group by key, get the iterable, then write a, say, custom Pardue to get the top in iterable, to then say, okay, yeah, SEMS is used the most often here, Flink is for the F words, N is for the N words. So that's one way to do it. But here's another, you can use group by keys followed by Pardues can often be simplified by combine. So there is a bunch of built-in combiners in the language spec as well. So again, I mean, you can do the same thing in different ways, but I generally would trust a well-vetted community-supported combiner to be as, if not way more efficient than an off-the-hand combination or combiner that I would write myself. So you could start with the same input and just run a combine per key for count and compare and get the same output as before, one less step, if you will. So count and compare, for instance, would be a combine function that extracts the top based on the input. So grouping transformations, there's a bunch of combined functions. So there's, top per key, min longs per key, count per key, max, mean, sum, the approximate quantiles, approximate unique. So, I mean, also, I think you guys know approximation algorithms might not give us the exact result, but will give us things quicker, and in many cases that might be more than, or might be the ideal outcome. Cool. All right. So then to talk about composite combinations, right? And I thought we were going to take a second for oh yeah. Since we just went through group by key, I'd like to give you guys a few minutes to work through the group by key example in the katas. So I'm going to set a new timer and give you guys 10 minutes on that really quick. Certainly, actually, I think we don't need 10 minutes. I'm going to give you 8 minutes. Please work through group by key. Let us know if you have questions or issues. And then we'll dig into some more of the pieces. Okay, I see a question from Karen. Is there an option for file IO watch like in Java? My quick answer is I vastly assume, but I would have to look at the documentation for the whether or not Python has specifically implemented that, right? These are potentially developed separately. That said, again, given portability, I expect that we're, I guess I wonder if we're going to start deprecating the IOs that are not parity in favor of whatever is implemented that is the most efficient, which then would mean I would expect for even in a primarily Python-based pipeline to be able to use the Java file IO to watch that. Hopefully that's an answer that makes sense for you. All right, cool. Welcome back. So the reason I wanted to make sure to focus on that really is between your pardo's and your group by key, you can express almost any bit of semantics that you would want for any batch, and in some cases streaming pipelines, but especially batch. The reason I say especially batch is after this quick section on composite, we're going to get into the many other aspects that must be thought about in a streaming pipeline around time. But as far as how to do actual transformations, let's say in a time agnostic fashion, your pardo's and group by key are gonna take you super far. And then again, it's about feel free to not just write custom code based on those, but leverage some of the built-in and optimized functions that we otherwise walk through. Cool. So as shared, other patterns or whatnot, pardo's can output multiple outputs. So a dead letter pattern is one common bit. Cool. So, yeah. So, for instance, if I do some form of validation, if the input to that was bogus, write it out somewhere. If not, it's clean and good, so continue the pipeline. So here's a wall of Java text, for instance, on how something like that can be implemented. Here is a smaller block of text on how this could be implemented in Python, for instance. Go can do the same thing. Oh, okay. So that was, then I wanted to run group by key here. So, oh well, we already did. So we're ahead of things. All right, so to dig into now the streaming bits, right? We have to think about where things are happening in event time. We can have data. We can have big data. We can have really big data, or we can have maybe infinitely big data. Data may have unknown delays, for instance, right? So we have this, something that happened at 8 might arrive at 8. It might arrive at, say, 8:15, or maybe it's actually not going to arrive until 14:30. Right? So like more than 6-hour delay. Maybe I click something and I'm on the airplane, for a cross-country flight, and then when I touch back down, then I'm able to send that event. So with element-wise transformations, the relative order doesn't matter a bunch, and I'm just say filtering things as they occur. A common processing pattern, historically has been processing time windows. So do, say, daily or hourly, in this case, batches and do, say, your counts and summations based on that. As you can see, this leads to not exactly correct results because, for example, these events that occurred at 8 o'clock did not wind up necessarily in the proper bucket to be summed accordingly. So, alternate way of doing things is to take the input as it arrives, but then re-bucket it and count it based on event time windowing. So take these events and here, right, and say that this event actually didn't come until 12:30, but actually, it was relative to the 11 o'clock hour. So that's when the summation should be occurring. For many things, that might be the right way to get the correct output. Event time windowing and windowing in general is about where in event time you want your computation to occur. So there's many kinds of windows. You can have fixed or tumbling windows, say hourly, daily. There are also sliding windows, which kind of slide along. But what isn't on this slide that we'll see on the next is sessions and how to compute those. Sessions are interesting for a couple of reasons. They are unique per key. So session for one user can be different than another, and they are not necessarily aligned across keys. Also, sessions can't be known ahead of time. I don't know necessarily when a user is gonna trail off, and even more problematic is what to do without a clear marker of end of session. Did the user's app crash? Did they hop on airplane mode, or did the battery die? Why don't I have that end marker? So windowing strategies also become interesting around sessions. So also triggers and streams. We need to think about when in processing time are we emitting results. In traditional batch pipelines, we might arrive at, say, the boundary of what we care about and say, all right, here's our group of data, let's start computing it. But if the, say, pipeline is streaming, it's not just that, hopefully not, but likely CSV file. How do we start deciding when to emit or actually calculate a result? So one shout out, I want to say this book by Tyler, Slava, and Reuven is fantastic. I really wish it would have had this other cover, the cover that could have been. So certainly check that out. Also, I am currently working on a stream processing pocket reference as inspired through, and working on that with these gentlemen. So currently Streaming Systems is available, very in-depth on all of these things. And you can get a more general summary in the pocket reference that should be out next year. All right, so streaming, what to do with unbounded peak collections, right? So we can do an event time shuffle of the data into distinct windows. And now that we're running streaming, windowing can still give us the where, but it does not specify when, right? So we can group these things, but when are we going to do things? So when is usually at some form of what gets determined to be the watermark. So here would be a, okay, so we're saying window into 2 minutes, sum the integers per key. So here's at the left what a perfect watermark can look like, and based on a heuristic watermark. So every 2 minutes, the time is progressing upwards. We are computing partial sums as we go. And as the watermark passes, we materialize the results. So we can get output as the input becomes complete while waiting until we think we have all the data. In the case of the perfect watermark, would mean we have perfect knowledge of the state of the system. The perfect watermark is not realistic in any, real production scenario. Also, you don't necessarily want to wait forever because of potentially late data. So, what do we want to do? In the case of just the traditional heuristic watermark, we would have emitted the result of 5, and the watermark would progress. We'd get, say, 7 and 8 there. I think, yeah. So we get to the point where we accumulate, I think the next window closes here and come up with 22, for instance. At that point, we would have kind of left this 9 behind, which for many use cases is entirely useful and necessary in the real world. We have to kind of forget about it. But in other cases, that data point might be important. So we need to decide the strategies that are important for us. So you can also add early and or late firings. So in this case, we're allowing early firings at a period of 1 minute, and we're allowing late firings at count of 1. So at any point a late arriving record comes, we need to fire. So the speculative triggers provide early updates before the full watermark is passed. The watermark will trigger on time when we think the input is complete. And we also added late firings anytime late data arrives. Naturally, this is up to real world limitations of how much data we allow our system to keep in memory for this to be a thing. I mean, naturally, we can get as complex as we want, but at some point, it's potentially not practical to do a late update data a year ago, for instance. Naturally, business and specific use case dependent. So again, we can see how the perfect watermark and the heuristic watermark behave when they're emitting various results and how the end accumulation is occurring. So here, the perfect watermark winds up with the same results. We wind up kind of getting the the summations in many cases earlier than we otherwise had based on the original code. And based on the heuristic watermark, we're able to benefit from the late firing and don't miss out on 9 in this case. There's a ton of other triggers, and we can certainly build more and more sophisticated triggers. This is not an exhaustive list of triggers, but some that you can have. So you can do updates every minute. You can do summarization every minute. You can get the eventual correct results. You can address too slow, too fast bits. You can fire early, late. You can do any sort of combination, right? So yeah, that's a good bit. Side inputs. So just saying, in addition to the traditional inputs, you can broadcast alternate elements. So for instance, the count of total elements to the full Pardue. You can also, slow arriving data in the sense of doing some sort of join. Here's Pardue with side inputs, for instance, in Java. And here we use, meaningful color. Here's just a quick bit on the Scala API SHIO, right? So we have, you can see that the Scala also works here. I guess I wanna, since this is, we're not quite done yet, but Beam is a community. So I, created a few of the slides, made some changes, but really I pulled a whole lot of these things from a lot of these people. So just like the open source project, we're in this together. Some more katas to be done. The other kata I'd encourage to address here would be the flatten, right? With group by key, with map and flatten, you can fully do the range of splitting, joining, and combining results. And in addition to that, then there's the highlights from the various time semantics that we just walked through. So I'd say let's both, I guess, give a few minutes for, let's do another 8 for flatten. And at the same time, it looks like actually I spoke way quicker than I usually do, which is awesome for time efficiency's sake. But by all means, after this, we can quickly walk through the remaining ways. I can highlight additional ways to get involved, but please, any questions, throw in Q&A, because we're getting close to being able to wrap up here. All right, cool. Hey guys, and everybody. I guess to share, some of these operations are super simple, right? Just as long as you know the actual SDK called beam.flatten, for instance. So hopefully just by, reading the, I don't want to right now. Oh, interesting. That's weird. I brought the website in there. Anyways, not a huge fan of the way the Python katas do log elements. I often, when I'm learning myself, or when I have been, I would change this to a text output to verify and be able to see it writing somewhere so that I knew what I was doing. I guess that's one tip I can share for learning, right, is you can take this code and run it outside of IntelliJ and try different operations and, just use the text IO, which would be the other maybe bit that you want to dig into is the text IO kata, for instance. Make sure you can read and write, read from and write to text files. Certainly dig into the, maybe let's, there's some other beam.apache.org website. You can check the documentation. At this roadmap compatibility matrix that I into that, which is getting much further developed. The programming guide is super helpful. Has specifics for both Java and Python. How to dig into windowing for instance, etc. I think those are some of the main bits. Apache Beam IO. Beam IOs built in, so file, for various file systems, file types, message queues, databases, etc. Check also, these things get updated pretty okay, but check in Jira, write on the mailing list, etc. Cool, let's see other bits. I'd be remiss to say, hey, I'm primarily employed by Dish Network. We're, even in this crazy time, we're hiring for all sorts of engineering positions. So if you're on the lookout, check out jobs or find me at, Bamboo Zoology is my Twitter handle. Let's see, which, I haven't actually used much, so try DMing me there on LinkedIn if looking for stuff. And then really can encourage more, get involved. This is an open source project and community effort. So as we just walked through the beam.apache.org website, check out Slack. Hopefully you guys are in the Apache Software Foundation Slack, given that you're a part of this Beam Summit. So there's a bunch of, Beam Python, Beam Java, etc. room, great place to chat. If you're really looking for help with stuff, though, certainly post your issues on Stack Overflow. There's a bunch of people who are actually working on Beam, building it, but that's kind of part of their job. And some of a lot of those people are in Stack Overflow looking to help people trying to build a great product. The mailing lists are a great way to get involved. So Beam dev at the, so how about beam.apache.org community? Yeah, so on the community page, subscribe to the user list, the developer list if you want. You might not want to subscribe to get notifications of all the commits going on or build notifications from Jenkins. Here's info to Slack and Stack Overflow and etc. So that's another good resource. Yeah, that's roughly what I got. And cool, yeah, what else can I be doing? I kind of repeat iterations of this, hoping to that people see the expressive power and great things that can be done here with Beam. So I'm happy to hear any more. I'm gonna stick around for a few more minutes, but if I don't see more things in QA or the group chat, I'm gonna assume that everybody has a good enough sense of what's going on, and to encourage to just enjoy the rest of your Beam Summit and stay safe and sane in this crazy world these days. Certainly work through, best advice, work through the katas if you have access again to the IntelliJ based or JetBrains based platforms. Working through each of those individual components will yield a good understanding to then continue building more and more complex pipelines to do what you need. Cool. So I'll be here probably quiet for another few minutes and we'll sign off without more QA or discussion points.